Welcome back to Algebra 2 homework help. Today we're going to be graphing horizontal parabolas. The problems from the homework are 1, 3, 5, and then from number 5 we're going to do B, D, and F. So first let's make sure we're on the same page with our notes. So up until now we've been dealing with vertical parabolas. That means that they open up and down. Our vertical parabolas would be like the old stuff that we've been doing. And the new thing are these horizontal parabolas, which open to the left or to the right. And the easy way to identify which way we're opening is basically, if you look for I'm going to make a note here, okay? It's a skull, as in very important. You're going to look for the variable, which I'm referring to the x or the y, that is not squared. I'd like you to make a note of this. To determine whether it's opening up, down, or left, right, we're going to look for the variable that is not squared. So have a look at our notes. Over here, the variable that's not squared is the y. Well, that means that I'm going to be opening up along my y-axis. The y-axis runs up and down, and as a result, our parabola is either going to go up or down, depending on the sign of this a. Whether it's positive, if a is greater than 0, we're opening up. If a is less than 0, we're opening down. But notice that y is all by itself, and so that's the direction that we're going to be opening along the y-axis, which runs up and down. Now, if x is the guy that's all by himself, and that's the case in our newer graphs, then we're going to be opening along the direction of the x-axis, which runs left and right. So if x is by itself, I'm opening up along the x-axis. If a is less than 0, then I'm opening up to the left along the negative. Actually, let me write that over here. That would make more sense. So if a is less than 0, that means a is negative. I'm opening up to the left. If a, that's the number being multiplied in front. If a is positive, that means it's greater than 0, then I'll be opening to the right. Okay, so let's do our first problem, number 1. We want to graph this parabola. Let's just start by figuring out which direction it's opening. So let's start right over here. So we're going to find the variable that is not being squared. In this case, that variable is the x. So that means our guy is going to open either left or right. How do we decide? Well, notice that our a value is the guy being multiplied on the other side of the equal sign. So we located this x. Now we're looking on the other side of the equal sign for the a value that's being multiplied in front of y squared. So I want you to ignore this number. That's not the number. Ignore this number. That's not the number either. We're interested in this guy, what's being multiplied. And right now that's an invisible 1. It's a positive 1. And since a equals 1, which is greater than 0, so it's positive, I'm going to be opening up in the positive x direction. This guy's going to open to the right. So that's just how we're going to be identifying, okay, which way is this guy opening? Let me rewrite the equation. Was y minus 1 whole squared. Okay. Now that we know it's opening to the right, let's talk about our vertex. So our vertex, as always, is going to be found by flipping the inside and then keeping the outside number, as always. But a slight change, okay? So our vertex, before we would flip the inside number and we would put it right here in the x spot. But notice that now the inside number is grouped with the y. So that means that when our vertex is x comma y, when we flip this inside number, we need to keep him with his buddy, which is y. So I'm going to flip that. It's going to become a positive 1, but it goes right there in the y position. And then we're going to keep the outside number, which is 2. Okay, let's find our x-intercept now. So to find our x-intercept, as always, we're going to set the other guy. We're going to set y equal to 0. So make a note to yourself. To find the x-intercept, set y equals 0. We really mean we're going to plug in 0 for y right over here. So let's show the work. X equals parentheses 0 minus 1 squared plus 2. We've got to use our order of operations, so we're going to focus inside the parentheses first. Okay, what's 0 minus 1? Well, that's negative 1 squared. Everything else, notice I'm writing it exactly the same. Okay, after our inside the parentheses, we do our exponents. So negative 1 times negative 1 is 1, plus 2 is 3. But our x-intercept isn't just 3, it's actually a point. It's somewhere along the x-axis. So I need to make sure that if I found the x-intercept, remember that was x equals, so that should go in my x position. And what goes in the y spot? Well, look back over here. What did we set y equal to? It equals 0. Okay, now we have enough information. Once we do these first three things, we have enough information to graph and then we'll answer the rest. So let's graph. I have a vertex at 2, 1. I have an x-intercept at 3, 0, and I'm facing to the right. So this is a common mistake that people make. They start graphing it incorrectly. That's not correct. It doesn't open down, man. It opens to the right. So keep in mind, this is our vertex, and we're opening horizontally to the right. Should look like this. Okay, so our axis of symmetry, that's the line that cuts this guy symmetrically down the middle. So for the first time, our axis of symmetry is horizontal. Notice that this axis of symmetry is going through the y-axis, and it's hitting the y-axis at the value of 1. So the name of this line is going to be y equals 1. That's our axis of symmetry. Whenever we say y equals, that means it's a horizontal line, because it's hitting the y-axis. Okay, our domain. Let's talk about domain. So scanning from left to right, I'm interested in all of the x values. So you might ask yourself, does the graph exist over here on the left at negative infinity? It does not. It begins only here at this value of 2. So it begins at 2, and then it extends forever onwards till positive infinity. So those are the x values. So it would be very smart to actually label your vertex 2, 1, and then when you're answering about domain and range, underline, so domain is about the x value, so underline the x value. So you don't accidentally say like 1 infinity or anything silly like that, because we want to say this point, our x value, domain is from left to right. Okay, let's talk about the range. So this arrow over here tells me that I'm going forever to the right, but it's also going forever downwards. So it will eventually cover all of these y values. And this arrow here is going forever to the right, whoops, but also forever upwards. So all these y values way up here are going to be covered. So if I'm scanning my graph from bottom to top, I will hit from negative infinity, all these y values are covered all the way until positive infinity. In fact, all of our horizontal parabolas will have this range from negative infinity to positive infinity. Even if it was facing this way, it's going forever downwards, forever upwards, so our range would have also been the same. All right, let's do another problem. Number 3. So as before, we're first going to identify the direction of the opening. So let's find the guy that's not being squared. That's x. So I know I'm opening along my x-axis, left or right. How do I determine which way? Don't be distracted by the +3. That's not what I'm looking for. We're interested in the number on the other side of the equal sign, but that's in front of the y squared, our a value, which is -1. Since it's negative, I'm opening to the negative x values on the left. So we're opening left. Okay. Now we can answer our vertex. So for our vertex, I'm going to rewrite this. We're going to flip the inside number. Now when we say inside number, we're talking about inside the parentheses. Remember, there's invisible parentheses here with the y. Well, when there is no number, we're really adding 0. There's nothing there. So the invisible number is 0. So I'm going to flip the inside number, but it doesn't go here as before. No, this is a different problem. We have to keep it with the y because it's grouped with the y. So we'll put the 0 here. We flip the inside number, and we keep the outside number. So leave that as positive 3. Let's find our x-intercept. So we're going to set our x-intercept. We've got to show our work. We're going to set the other guy. That would be y. Set y equal to 0. Let's do it. So x equals negative 0 squared. If you want to be really meticulous, leave those parentheses, and then plus 3. So let's do our exponents first, since nothing can be simplified in our parentheses. What's 0 times 0? 0. What's 0 times the negative out in front? Still 0. What's 0 plus 3? 3. You're so good at this. Okay, now careful. We have to write the x-intercept as a point. Remember, points have 2 numbers, not just 1. So go back here. Where does that 3 go? Does it go in the x spot or the y spot? If you said the x spot, you would be correct. That's because it says x equals 3. And remember, we set y equal to 0, so this should be 0. Hey, it looks like our vertex and our x-intercept are lining up nicely. They're the same point. So once I've got these 3 things, I can start graphing. Let's go to 3, 0, right there. That's my vertex and my x-intercept, and I'm opening left. Should look like that. I can make it nicer if I want to. And I do want to, so there we go. All right, our axis of symmetry. It's this line right over here. And it's hitting the y-axis, or it's crossing through the y-axis at a height of 0. So our axis of symmetry is y equals 0. Remember, this y equals is how we know it's a horizontal line. If you're tempted to say x equals 0, you're thinking of this vertical line. So go to the side, make a note to yourself if you get confused. Y equals would be horizontal line. Y equals some number. If you have x equals, you're dealing with a vertical line. All right. Let's talk about our domain and our range. So, our range we already know is from negative infinity to positive infinity, because these arrows are going forever down, forever up. So all of our y values are covered. Let's talk about our domain. And as I said before, it's very smart to label this point. This is 3, 0. And domain focuses on the x values. So let's underline that 3. We know it's going to be part of our domain. So the question is, from where to where, scanning from left to right? Well, on the left side, at negative infinity, does the graph exist? Heck yeah, it does. Both of these arrows are going towards, we're going to cover all those negative values. So from negative infinity all the way up until, stop right there. That would be 3. And since I exist at 3, I'm going to include it by using brackets. Notice I did the same thing here. I included 2 because I did in fact exist at the x value of 2, and I went forever to the right. All right, so we are done. We're almost done, actually. We have only one more problem. Okay, for number 5, so I love these problems because there's no work to show. You just use the tricks we talked about earlier. So for these ones, we just have to identify, or ID, the direction of the opening. It's like a quick check. Is it opening up, down, left, or is it opening to the right? So as before, we're going to find the variable, the x or the y, that is not being squared, right? Find the variable not squared. So let's do A. Let's do B. Okay, the variable that's not being squared is the y. So that means I'm opening along my y-axis. That's either up or it's down. Y-axis runs up and down. Now, which is it? So to figure that out, we look at the other side of the equal sign. Don't be distracted by this number, and don't be distracted by this number. I'm interested in the A out in front. It's a negative, so I'm going to open down. looks like this. All right. D. Try it yourself. We're looking for the variable that's not squared. Which is that? If you said y, you're correct. This is another up-down. Now, which is it? Is it opening up or is it opening down? So, you should be looking at the other side. Just like we said here, look at the other side of the equal sign. Here you're going to look at the other side of the equal sign. Don't be distracted by this 2. Don't even be distracted by this -5. It's a positive out in there, out in front. So we're going to be opening up, not down. Opens up. Okay, let's do one more. Find the variable that's not being squared. We're on F now. All right, that's x. X is not being squared, so I know I'm opening up along my x-axis either left or to the right. Let's see, I need to look at the other side of the equal sign to figure out which it is. So I hope you're not looking at this number, and I hope you're definitely not looking at anything on this side. The a value is -4. So I'm going to open to the left. But, oh my gosh, not so fast. This is a trickier problem. It's a tricky problem for this reason only. See how, okay, we got to rewrite this. We've got -3, x minus 1 equals -4, y plus 2 whole squared. Okay, see how the number in front of x minus 1 is negative? And remember, this is our a value. This really is the a value we're looking at. But usually we don't have a number in front of the x or the y that's not being squared. So watch what I'm going to do here. I'm going to divide both sides by that negative number. And when I do that, I'm left with x minus 1 equals, this becomes a positive 4/3, y plus 2 whole squared. Now this is what we really should be working with. So F was a tricky problem because even though A looked like it was negative, it was actually kind of deceiving because we had to get rid of that -3 through division. So I want you to focus over here. Okay, the variable that's by itself is still x, or sorry, the variable that's not being squared is still x, so it's either left or right, but your a value is now positive. So is it opening left or is it opening right? Well, it's opening to the positive x value, so it's opening to the right. It's this guy. Opens right. So you know all that work that I did up here, where I said, oh, it's opening left. Yeah, that would be wrong. That's because that was a tricky problem. It had negatives on both sides. It was really a positive a value. So we had to do a little bit of work. This guy's really opening to the right. Okay, hopefully that was helpful for you. I look forward to seeing you back.